Hello everybody. This video I'm going to be looking at problem number 5 from the Princeton math competition in 2017, and this is the geometry round. So we have rectangle HOMF has HO equal to 11 and OM equal to 5. Triangle ABC has orthocenter H and circumcenter O. M is the midpoint of BC and F is the foot of the altitude from A. So and we want to find the length of BC. So here, let's start by drawing the triangle. And now obviously this is a very rough sketch, but so we have the triangle ABC, and here M is the midpoint. It's probably very off. And we have this altitude F, or AF. So here we have these nice 90-degree angles, obviously because OM is the perpendicular bisector, and then AF is an altitude, and H is on AF. So we have everything in order here. So we have these lengths 5 and 11, and we wish to compute the side length of BC. And so, we have a midpoint here, so maybe we could calculate MC, right? And what would we need to do that? Well, we would need the circumradius, R, to compute that. If we knew what R was, then maybe we could figure out information about MC. And here comes the magic part of this is if you've watched any of my Olympiad geometry videos, then you will know that the 9-point center of a triangle is the center of a circle that goes through midpoints and feet of altitudes of a triangle. And specifically, the 9-point center is the midpoint of H and O. And so it is right there, N. More importantly, the radius of this 9-point center, or the 9-point circle, really, the 9-point radius, I should call it, is half of the circumradius because the 9-point circle is a result of a one-half dilation at H. That's why it's the midpoint of H and O. And like I just said, the circle passes through midpoints and feet of altitudes. So here we have, we can just connect N and M, and we have a right triangle with two side lengths that we know. And then that will give us, this will be R over 2. So now we're in the business. In other words, if we just scaled up this triangle, because this length NO is 11 over 2, so if we scaled up the triangle, we would get 10 and 11 would be the legs of a right triangle, and the hypotenuse would be R, capital R. And so that just implies that R is equal to the square root of 221. So now we return to this right triangle OMC, and if we apply Pythagorean theorem again, we'll get that MC is equal to 14, and therefore BC is just equal to 28. And so if you don't understand this 9-point circle stuff, I have videos on it, so you can go watch those. But anyway, I hope you liked this video, and I hope to see you in my other ones.